Determining rate of change or slope and y-intercept from a table. For each table, find the slope or rate of change and the y-intercept. All right, let's highlight our vocabulary here. We are trying to find the slope or rate of change. Remember, slope is just your rate of change on a graph. And we are also trying to find the y-intercept. And previously, we did that on a graph. Here, we're going to do it with a table. So let's take a look at this. I'm going to zoom in on number 1. The table shows a linear relationship between x and y. So if we were to plot these points on a graph, they would be in line together. They would make one line. Here's how you find the slope from a table. It's the same formula that you had before. It is, ooh, that is too big. Let me get a smaller pen. It is y2 minus y1 over x2 minus x1. Okay, now let me label my rows of my table the same way I labeled my points before. So I'm going to call this x1, y1. And then let's just use the second row. It doesn't matter which row you choose. x2 and y2. Beautiful. So now I have some values that I can substitute into my formula. Let's see. y2 is 31. y1 is 24. x2 is 2. And x1 is 1. So 31 minus 24 is going to be 7, and 2 minus 1 is 1. Beautiful. So that's my slope. My slope will be 7. I could go ahead and write that down. I don't need to write the 1 in the denominator. It's sufficient to just write the 7. But that 1 does have meaning because it tells me that when I go up 7, I'll be going over 1. All right, now I want to show you something else important in this table. For one thing, I didn't have to use that formula, and I did not have to label those points. I can just look at the difference between the rows. This is plus 7. This is plus 1. I could see it right there. I could also have chosen a different row. Let's see what happens here. Let's see, 45 plus 14 is 59, and 4 plus 2 is 6. Now you might be thinking, hey now, 14 is not the same as 7, and 2 is not the same as 1. But remember, when we talk about slope, we're talking about a ratio. So I have a ratio of 14 to 2, and that is actually equivalent to 7 over 1. It simplifies to 7 over 1. So the slope is same whichever row of the table I choose to use. It's going to be 7 over 1. Now my y-intercept is actually not in this table because my y-intercept is going to be the point where x is equal to 0. It'll be 0, and then there'll be some other number. That other number is my y-intercept. This table doesn't have a y-intercept in it. It doesn't mean the line doesn't have a y-intercept, though. The key is to know that this table really extends as far down as you need it to, and it extends as far up as you need it to. Let me see if I can make it a little bit easier to imagine that. There we go. I just added some extra rows to that table, right? Well, I know what the pattern is. I know that if I add 7 here, I'm going to add 1 here. If I add 2 here, then I'll be adding 14 there because 1 plus 1 is 2 and 7 plus 7 is 14, and so on, right? So what if I wanted this to be a 0? Well, 0 plus 1 is 1. So then what number, if I add 7 to it, gives me 24? Really, I just have to think, what's 24 minus 7, right? The number that goes right here must be 7 less than 24. Let's think about what that might be. 17. And you know, we could keep going if we needed to. I could take away another one. So negative 1 plus 1 is 0. It's not necessary to do this, but I know that 10 plus 7 is 17. I could go back as far as I wanted to, but I don't have to go any further back than this because I can already see that my y-intercept is at 0, 17. So I'm going to write down 17 as my y-intercept. Now I'm going to show you some magic. What I want you to do is use Desmos to check your work here. Let me tell you what to type into Desmos exactly. So remember, we had our table. It was x, y, right? So I want you to add a table in Desmos, and I want you to enter in these points to your table. It's going to look a little bit different in Desmos you are going to notice that it doesn't just have x, y, it has x1, y1, right? Okay, go ahead and enter in your table and then hit play when you're ready to do the next thing. But everybody needs to have this table entered into Desmos. All right, if you've hit play, you must be ready for the next step. We know that linear equations use this formula, y equals mx plus b. And the reason we know that is because it was a part of 7th grade math and also because it's on our reference materials. This is on your formula chart. You do not have to remember it as long as you know what it means. What we're going to do in order to have Desmos find this equation for us is we are going to click this little button that looks like that. Do you see it? It's at the top left of your table. It should be right beneath the plus sign. It's like a diagonal line with those dots on either side. I want you to push that button and watch the magic. It should give you an equation, and the equation it's going to give you is y equals 7x plus 17. So it'll tell you that. Now, that's a little bit extra for us because this problem didn't actually ask us for the equation, but we've got it for them anyway. What this question wanted was the slope and the y-intercept. Well, here's our slope, and here is our y-intercept. And if you ever have difficulty remembering which one is which, remember that on your formula chart, you have this formula up here, and you also have the slope formula. You might say, well, which one is the slope? Is it the m or is it the b? Don't worry, your formula chart is going to tell you that the slope formula starts with m, so you don't have to remember that, but you probably will remember that slope is the m, because we're going to calculate it like 1,000,000 times this year. Okay, so we have our slope, we have our y-intercept, and we have checked our work. Let's do another one. This one has a table that goes from left to right. It's a horizontal table. You might find it helpful to rewrite the table vertically, but you don't have to. But just in case you want to, let me show you what that looks like. That's how this table would look vertically, and it means the exact same thing. So now we're going to find the slope from this table. I'm going to find it horizontally because that's just fine with me. Let's see, 11 minus 3 is 8, so that's my change in y. Let me label this change in y over here, and here I'm going to calculate my change in x. Okay, 1 plus 2 is 3. Okay, so I could already write that my change in y over my change in x is negative 3 over 2. Let's just check some other rows and see if we get the same thing. Well, here I get plus 3 for my change in x. And here I get minus 4.5 for my change in y. That looks different. Let me write that down. Negative 4.5 over 3. Tell you what, I am wondering, are these two the same or are they different? Let's pause a minute and just look at that. Are these the same or are they different? What I want you to do is type these in your calculator. Type negative 4.5 over 3. And then on a separate row, type negative 3 over 2 and see what it gives you. Yes, it's telling you that they are the same value. They are equivalent ratios. Negative 3 over 2 is equal to negative 1.5, and so is negative 4.5 over 3. And they can both be written as negative 3 over 2. You could also get that using your slope formula. Here I substituted values into x1, y1 and x2, y2, and I got negative 3 over 2 that way as well. So that's another way you can get it. We are finding more ways to find slope every day. And now let's talk about what the slope would mean in this situation. We know that slope is comparing the height of the candle to the number of hours it's been burning. So it might actually help to think about what this would look like on a graph. So I drew a graph for us right up here so that we can see what's going on here. Our y in this case is the height of the candle. What's happening to the height of the candle? Yes, it's getting smaller. The candle's getting smaller because the candle is melting. And so here's my number of hours down here, and I could actually connect these if I wanted to. That's why we call this a linear relationship, because all these points together are on a line. So our candle is melting is what's going on, and the slope represents the speed at which it is melting, the rate at which it's becoming shorter. There we go. So the slope represents the rate at which the candle is melting in inches per hour, and it is a negative slope because the candle is getting shorter. Once again, our y-intercept is not shown to us in this table, but that's okay because we can figure it out. So once again, I have extended my table. I really like that strategy. And now I can think what happened before the candle had been burning for 1 hour. Remember, this is my hours, and this is the height of the candle in inches. So if I were to go backwards 1, I'd be at 0, right? So 0 plus 1 is 1. And then I have to think, what would I add in my y's? Well, to go from 11 to 8, I subtracted 3. So I only want to do half that here, because to go from 1 to 3, I added 2. So when x increased 2, y decreased 3. When x increases 1, y should just decrease half of 3. So it should go down by 1.5. It's going to decrease 1.5. So what's 1.5 larger than 11? It would be 12.5. So that must have been the original height of my candle. It must have been 12.5 inches tall. Now, I will tell you, finding that 12.5 inches, that was a little bit challenging, wasn't it? I had to really think and work backwards. I had to say, well, what's half of 3? This is a great opportunity to use Desmos and see what Desmos says. And there's actually another way that you can get this too. Remember we used this formula earlier? We say we had y equals mx plus b. Well, we already know what m is. We know that it's -3/2, right? And we know what x and y are too. All of these values right here, these are x's and these are y's. I just need to pick one good pair, a pair that I like. I think I'm going to choose 1 and 11 because 1 is a very easy number to work with. No decimals, and it's easy to multiply by 1, right? So I'm going to substitute 1 for x. Well, when x is equal to 1, y is equal to 11, and we don't know what our y-intercept is, right? Except really we do, because we already found it. We know it should come out to be 12.5, but this equation is another way of letting us see that. So we have 11 equals, let's see, -3/2 times 1 is just -3/2. And I'm going to write it as -1.5 because we know 3/2 is the same as 1.5. You could type it into Desmos to see that. Now I just have a little equation to solve. Let me add 1.5 to both sides. And that's actually what we did in our table, right? We said 11 plus 1.5 was 12.5. Well, that's going to happen here too. So we're going to have 12.5 is equal to our y-intercept. So we can find that y-intercept through substitution as well. That might be an easier way. I want you to know that both are good ways to do it. You can think backwards from your table. You can solve for your y-intercept by solving an equation and substituting x, y, and the slope. Or you can use Desmos, and that's what I want you to do right now. So in Desmos, I want you to enter this table. We have 1 and 11. We have 3 and 8. We have 6 and 3.5. And then we have 8 and 0.5. I want you to enter this table, and then I want you to click this button. And what it should tell you is that y is equal to -1.5x plus 12.5. Right? And those are the values that we found. Our 1.5, our -1.5 was our slope, and our y-intercept is our 12.5. So what does the y-intercept represent in this situation? It represents the starting height, or you could say the initial height or the beginning height of the candle. That's originally how tall the candle was. That's our y-intercept. If we were to add that to our graph, because we can now, it would be right here. That would be 0, 12.5.